Stable Diffusion had a safety filter that was broken down with just $1, a science prize of $250,000 to test how long AIs can stay aligned the bigger they are. OpenAI will remove their human review and replace it with automation right after an exploit is discovered, making it more vulnerable. The Open Worldwide Application Security Project, OWASP, launches the AI Exchange and splits prompt injection into two categories. This is AI Under Attack, Episode 10. In the month of 2022, every shortcuts to AI safety will die. We're going to explore the safety filters, see exactly how it works, find out why adding random words is all it takes to break it. We know that prompt injection was named last month and that Stable Diffusion's filter was bypassed in August. So this month, ETH Zurich, a research university, will discover prompt dilution. That means adding random words to bypass the filter by reverse engineering it. And this will break the myth that making AI smarter will make the problems go away. On their paper Red Teaming the Stable Diffusion Safety Filter, they found that you could fool Stable Diffusion Safety Filter just by adding random innocent words to any banned prompt. And they called it prompt dilution. And here's how it works. When you type a prompt, the filter will convert your words into a mathematical fingerprint. You can think of it as a barcode for meaning. Then it compares that barcode to 17 banned concepts barcodes. If they match closely enough above a 0.5 similarity score, then the image is blocked. So we can see an example here where a photograph of an astronaut riding a horse will get converted into its cosine similarity, then it will get cross-referenced with the concepts, and it will compute the similarity with a score from 0 to 1. Then if they verify if there's a explicit content, then it will say yes or no, below or above the threshold. The attack was quite simple. You could keep your original prompt, then pad it with a couple random words, mountains, oceans, forest, sunset. Each words would shift the fingerprint, kind of like context poisoning or adversarial perturbation, like we've seen with the text models. The other devastating part was that you didn't need to know what the 17 banned words were because you're not reverse engineering the blocklist. You're just adding enough noise so that the similarity checks breaks. This shows us that prompt dilution has parallel similarities with prompt injection. If you can do this with text to text, then you could also do that with text to image and vice versa. This is all because the input is accepted as one input stream. The researchers didn't just fool the filter, they cracked it open. Stability AI tried to hide their safety rules by scrambling the code and encrypting the banned word list, but the researchers broke through all of it in a few days for less than $1. They found that it was a single function checking against 17 banned words. All 17 of these words were about explicit content, nothing about violence or gore. And in episode 4, OpenAI was using a similar cosine approach with their DALL-E 2 model. The second finding would go deeper. The inverse scaling prize would offer $250,000 for anyone that could prove that bigger language models would perform worse at certain tasks and not better. It would receive 43 submissions where the winning categories proved that larger language models were most susceptible to prompt injection. This comes down to a problem that we saw in episode 1. The whole point of making models better This comes down to a problem that we addressed in our first episode. The whole point was making models better at following instructions. That means that larger, more capable models are dramatically better at understanding and executing complex instructions. But that also includes injected instructions. So when someone says, ignore your previous instructions and do this instead, the bigger the model is, the better the understanding of that command, and the more the execution will be performed faithfully. So the feature is the flaw and it will scale. They found that all 4 winning tasks would share one feature. The model's training knowledge would fight the instructions, and the bigger the model were, the more they would side with their training every time. The first task was redefine math. They would tell a model pi is now 462, and then they would ask, what's the first digit of pi? All the small models would say 4 because they would follow the instructions. However, when they use big models, they would say 3. They would follow their training data and ignore what you told them. The second one is quote repetition. You would tell the model, repeat exactly to be or not to be with the capital or not. And then the small models would repeat it, but the big models would autocorrect it to be or not to be, because they've memorized the real Shakespeare. They're correcting the quote while ignoring the instructions. The same pattern would happen with the negation questions and the hindsight neglect. The training patterns would override the logic by using the bigger models. So why is smarter more hackable? Well, making models better at following instruction is a feature. The training data knowledge scales with the model size, so bigger models remember more and therefore they can leak more. And now we can see that prompt injection vulnerability will also scale with model sizes. Because bigger models will be better at following the injected instructions, just like they're better at following the legitimate ones. The capacity that makes AI useful are the same capacities that make AI exploitable, and all of them will get worse as the models get bigger. While researchers were publishing devastating findings, two institutions were starting to build a response. First, OpenAI will update their API safety policies by shifting from pre-approving every application to monitoring outcomes automatically. This would be more practical for OpenAI, but that also meant that the threat of prompt injection would now grow wild. And the second one, arguably more consequential, Rob van der Veer will found OWASP AI Exchange. It would be a specialized subdivision of OWASP, the organization that defines the top security risks for every web application in the world. Over 70 plus experts will start building AI security standards. They will formalize a critical distinction between direct prompt injection, where the user types the attack, versus indirect prompt injection, where an attack is hidden in something that the AI reads. That split will become the standard for every security researcher's talks about prompt injection from this point forward. This will eventually lead to prompt injection being ranked number 1 risk on the OWASP top 10 for LLMs in 2023. A research paper isn't just about breaking a system, it's also about making an argument on how to fix the problem. Stability AI hid their filter code through a classic security through obscurity. That means keeping the mechanism secret and hoping that nobody looks. But their researchers decoded it in days. But there's a deeper flaw here, one that directly links to prompt injection. Clip, the AI model that converts the images and text into numbers, uses the same mathematical space for both image generation and safety classification. There's no architectural wall between content and control, the same way that adversarial perturbation would process as a single input stream. So when you add random words to your prompt, you're shifting Clip's understanding of the image, and the same shift would fool the safety checker. It's an instruction data conflation, but in image form. The same reason that text-based prompt injection works is the same reason that prompt dilution works. The model, again, has no way to separate your content from its instructions. Their recommendation was to publish the safety methodology and let the community audit it. They would be able to find the gaps and suggest improvements. Being open about it didn't mean they were weak, but open means that many eyes can find bugs. The same way that Entropic's red team would release over 39,000 attack adversarial examples. Now let's put the two findings together because individually they're concerning, but together they're devastating. Prompt dilution says you can't filter your way out, and any safety filters based on a single mathematical check can be defeated by adding noise. The attackers doesn't even need to know what's being filtered. Inverse scaling says you can't upgrade your way out because making the model smarter makes it more vulnerable to prompt injection, not less. And their $250,000 prize will prove this empirically. So you can't filter your way to safety because prompt dilution will defeat any single check similarity filters with no knowledge of what's banned required. You can't upgrade your way to safety. The inverse scaling prize would prove that the larger and more capable models would be more vulnerable to prompt injection. And obscurity is not security because ETH Zurich were able to reverse engineer the hidden filters in days. OWASP and OpenAI both will move towards a transparent, community-audited standard. The instruction following paradox from episode 1 now has a $250,000 in empirical proof behind it. So now the AI industry can close off their two most obvious paths to security. Safety filters breaking with noise and smarter AI is easier to hack. But what happened next makes all of this much bigger. On November 2022, Perez and Ribeiro will publish Prompt Inject, the first systematic framework for testing prompt injection. And ChatGPT will finally be launched, putting all of these vulnerabilities in front of 1 million users in 5 days. Over the last 10 episodes, we've watched research papers, safety bypasses, jailbreaks, and backdoors pile up. Discovered all in labs, posted on Reddit, and debated at workshops, while the rest of the world has no idea any of this was happening. Prompt injection didn't even have a name until episode 9, and now every obvious defenses has been dismantled one by one. Everything we've covered has been building to this moment.